Hello, Timothy Mulcahy here. Talk about something important in my research project here. Important for a lot of people I know is exercising and specifically exercising without getting hurt. So for this project, we built a deep learning model for automated form correction for exercise, specifically for back squats. So improper form during weightlifting, certain, especially and specifically back squats, can lead to a tremendous amount of injuries, not to mention the sort of reduce the effectiveness of the time you're putting into working out. And normally, you might need some expert guidance to do a proper back squat. A personal trainer, a fitness trainer, a coach, a strength and conditioning coach or trainer. These things aren't always accessible to most people, not to mention that they can be very expensive as well. Um, so, we decided to come up with this system in order to sort of democratize that and make it more accessible to people. So some of the technical challenges we ran into with trying to judge squats, there was no existing data sets really, so I had to come up with a fresh data set with a lot of videos sort of capturing squats. Originally in the project, we were going to look at not just squats, but also deadlifts and pull-ups, but sort of in the limited amount of time we had. Um, and data sets not existing for deadlifts or pull-ups either. We honed in just on squats because these are probably most likely are the exercise that leads to the greatest amount of injury in people. So the no existing data sets is the biggest challenge probably. It's also back squats, a very complex dynamic movement, lots of angles, and lots of joints are taken into consideration. The ankles, the knees, the hips, the shoulders, the back, head posturing, all this needs to be taken into consideration when judging a squat. And slight variations can cause all sorts of problems. And then to get all of these train models working on a mobile device and to be fast and efficient and user friendly on top of it can be a technical challenge for sure. There are some related work that exists out there, not specifically for back squats, but the open pose framework has a tremendous amount of stuff in it. Very neat framework that is very complex, very high tech. In a way, it can look at many different movements, poses, and take many different angles, joint positioning, complex, sort of dynamic movements, and judge them. Something called DesNet 2, which is a sports sort of neural network, does something very similar. And so these were two frameworks, existing frameworks that we sort of looked at and I got some ideas from. So for the approach for this, we used a TensorFlow-based neural network to analyze the video frames of the back squats to assess the form and sort of integrated an autoencoder to sort of detect anomalies and then deviations from our training data when we were testing it. And then converted this model to TensorFlow Lite and put it onto a Motorola Android phone, and then built the Android app around that to run TensorFlow Lite, take these short videos, and then as soon as the stop recording is done, then the video runs the inference on the video. The Android application rather runs the inference on the video and gives you a feedback score from 0 to 100 based on how well the model judged your back squat. So for the data set itself, we had to come up with the whole data set. It took nearly 2,000 video clips of lifters, doing back squats, experienced lifters. And we had a certified fitness professional there the whole time to judge each squat that someone did as we were filming it and trying to make it as perfect as could be. The model provided a feedback score based on how well the user squat, aligned with the ideal form like we were talking about. The results showed the model was, pretty close to that of what a fitness professional would say was a good squat. So, the model was definitely able to sort of notice major posture deviations and provide some feedback. There are a lot of challenges that with creating this data set, background noise, overfitting, failure to detect small deviations is very difficult for the camera to pick up and for the model to detect. And 2,000 video clips sounds like a lot, but we really need a much, much larger data set to work with in order for this to be, very, very accurate. I think this could have a much broader impact. If the data sets were developed farther and the neural networks developed farther, um, this could be something that many people could use. Sort of democratizes, form correction and not needing, a third party to have to pay to, correct your form. And this model can be adapted for different exercises as well. Integrated into fitness apps, could be used for physical therapy and rehabilitation. Um, so there's a lot of room in there, I think, for helping people out. The model struggles right now with sort of, when we're talking about diverse body types, environmental factors, lighting, background, clutter, clothes shading, different things like that, overgeneralization. So to prove it in the future, we can expand this data set, maybe we get 10 times the data set we have, take more, models into considerations, different people doing the squats, different sizes, heights, weights, all sorts of things. I think incorporating some supervised learning in there to be able to label bad squat data would be very important. And sort of further model refinement to handle these subtle deviations to make the model more robust would be very good. Here's a quick video of how the application works. So thank you very much for watching my presentation.